Okay.
All right, I'm going to be honest. I was expecting more of a packed room. This is right after the keynote. We didn't do a very good job advertising the session, though, because we had, I'll be honest, I asked ChatGPT to create the previous title, the unembargoed title. And then this is like a way better title than what I had before. But this only went live yesterday. So, yeah, wow, woo! Yes, I know, right? I know, it's very exciting. And so, I don't know, do people want to like sit more towards the middle, or we can just look right at you, sir, and just talk to you the whole time? The slides, what's wrong with them? Oh, you're looking at the slides. Oh, that makes a lot of sense, actually. Oh, you're not looking at us. I got it. Okay. All right, that makes sense.
That makes me feel better too.
No one's looking at us. Okay, cool. Well, so we're really excited. We're going to be talking about, I think we have 40 minutes together. I mean, actually, maybe less. We're talking about open sourcing Unity Catalog. Oh, no, what's happening? I don't know how to exit this.
Here.
Wait. Okay. This is really hard.
Huh? Okay, there you go.
Oh, okay. Oh.
Here you go.
Nailed it. Oh, wait, you're doing it with this?
You can go, yeah.
The clicker?
Yeah.
No, it's not working with the clicker. I'll just use the.
What?
You have to. I'm pretty sure it's not working.
It's not working.
This is it's really hard. So we have a demo. So that's why we have 2 laptops set up. We have a lot of cool demos, and I want to make sure we get to that. So we'll just keep going. We'll skip the stand-up comedy routine. Okay, so who are we? Michelle, product manager here, previously at Webflow and Airbnb, based in San Francisco. Talk to me about Delta Lake. Talk to me about Unity Catalog, interoperability. Talk to me about Unity Catalog open source, and then also where to find the best burritos in the Mission neighborhood. And then I'm joined by Ramesh.
And I'm Ramesh. I've been at Databricks for 3 years, and before that I was at Google. And I'm an infrastructure engineer. And talk to me about UC, governance, security, systems, anything. Yeah.
I think we can talk to you about anything. Honestly, you know everything. Okay, cool. So agenda, we're going to talk about a few different things today. First, we'll start off with like a very high level. What is a catalog? Hopefully everyone here knows it. But I think it's good to start at the basics. Talk about challenges today that we've heard from customers and from folks. And then Unity Catalog open source. And then we're going to do some demos. And then we're going to talk about roadmap ahead. Okay. Let's see, no one left the room yet, so that's good. Okay, so what is a catalog? I'll start off here. I gotta stand behind this podium. I guess I'll first start with maybe the like high level kind of marketing speak, but basically a great catalog enables you to manage your data and AI assets in one place, govern assets through single source of truth, leverage best of breed tools with your data. This is where we started Unity Catalog several years ago. This is the thesis that we started with, is that we wanted to accomplish these things. And so what does that mean? Catalogs are basically the source of truth for critical properties about your assets. They're the source of truth for things like table metadata, for lakehouse formats, table name, schema, storage location, et cetera. Governance and access control, like roles and permissions, users and groups, AI, ML object metadata, model name, model version, inference endpoints, whole bunch of different things, right? And then we're also seeing modern catalogs kind of evolve to also now take a role in complex transaction management. Okay, cool, I see people taking pictures of the slide. Here, I'll finish the build so you can take pictures of this. Table version, latest commit, right? And then in the future, something that we really want to enable and that we're really excited about is like multi-statement and multi-table transactions once you have this catalog as this sort of central coordinator. Okay. So we've established catalogs that become the source of truth for metadata, and that powers a lot of really awesome things like governance, discovery, lineage, monitoring and observability, and really cool and advanced features. And so what we saw though, and this is kind of the question, is so now catalogs are the source of truth. They seem great, they're powering all these like, incredible features, but how do I get various tools and platforms to interoperate with my catalog? And so there's a lot of challenges with that today, and I'll pass it over to Ramesh to talk through some of those.
Yep. Yeah, so let's talk about the challenges today. So we talked to a lot of customers about the challenges they face with today's catalogs, and we consistently see 3 themes, right? So the first one is that most cloud platforms lack open access, and this can result in vendor lock-in. The second is that data and AI assets are in an organization, they're arbitrarily siloed, And this means that workloads that need to access both data and AI assets, they find it hard to do so. And finally, the governance is super important for organizations. For any enterprise, they need to make sure that they have the right access control policies, they have the right auditing, etc. And doing that across data and AI is today, it's inconsistent and it's hard. So let's look at each of these in a little bit more detail, right? So many cloud platforms lack open access, and this itself can be decomposed into two parts. There's lack of access to open access to the data, and then there is lack of access to the metadata. So many cloud data warehouses have their tables in their native formats and not in an open format, which makes it hard for external engines to directly access this data. And furthermore, they can have, even the metadata that's stored in them can be stored in proprietary catalogs, which means that even the metadata access is hard for external engines. And many of them require always-on compute for even access to the metadata, which can be expensive and which can create vendor lock-in. So that's the first challenge which we've heard from customers. The second challenge is AI is super important, but the data and AI assets are siloed from each other. Traditionally, the catalogs traditionally have been more geared towards tabular data. And so users had to store their AI assets somewhere, their unstructured data somewhere, and that they used different storage systems for that. So if a workload needs to access both of these, then it becomes hard for them. It becomes hard both to discover and both to access the data. This can lead to duplicate, inconsistent behavior. For example, let's say in here I can have my product information can be stored in a tabular format, and it can also be stored in images, let's say, on unstructured data. It could be that my customer reviews are stored also in a table. They could be also stored in text. And a team that is building a model might only use the unstructured data. They might, like, for example, generate a text sentiment model out of your textual reviews. And there could be another team which is using the tabular data to generate a sentiment score. And they can be using the corresponding tabular data. So in addition to creating duplicate work for these teams, because these teams didn't know that that the other team is doing the same work, it can also lead to poor performance because the models become better if they have access to all of the data, but in this case, they'll only have access to part of the data. So the third problem which we've heard from customers is governance. As I said, governance is very important for enterprises, and it is not optional, it's regulatorily mandated. But governance becomes inconsistent and hard. Many open catalogs like Hive did not come with governance built in. So which meant, like, first they encouraged a pattern of giving, if you wanted external engines access, you have to give external engines direct storage access. And this can lead to either giving too broad an access or too limited an access, which can bypass governance, right? So, as an example, let's say you have two tables, a product table and a users table, both of them within the same bucket. The administrator gives access at the bucket granularity, let's say. And then if you have a user who's coming from an external engine like DuckDB, and they need to get access only to the products table, but not to the users table, this scenario, it becomes hard for the administrator to support that. Now they have to go back and rethink how they will grant access to underlying storage. And this makes it hard for administrators because now they're mapping higher level object accesses to underlying storage, and they need to keep this mapping up to date, and they need to kind of keep that in mind. That's very, very hard to manage. So in addition to this, silos also lead to fragmented governance. So if you have data and AI assets separated in different systems, now administrators will have to duplicate their access control policies across both of them. They need to keep them consistent. And that increases the burden, and it can also cause security bugs because the policies if the policy is inconsistent. Auditing is also hard because each system comes with its own audit logs, and the administrators have to stitch together all the audit logs to get a complete picture of the system. And a similar problem happens for lineage. Lineage has gaps because each system is tracking its own lineage, and now combining the lineage becomes a problem in itself. So over the last 3 years, we've built Unity Catalog as a next generation catalog, taking into account all these problems, and we wanted to address these challenges while we're building it. Michelle is going to talk to you more about that.
Yeah, all right, so we set up all those problems. This is the slide you should take a picture of. I'm pretty sure I updated it just before this talk too. So this is what we built Unity Catalog for, right? We wanted to have this universal catalog that enables any engine with this very rich client ecosystem to be able to access all of your data and AI assets that are governed within a single catalog. And so, I see the captions are kind of covering up some of the stuff at the bottom. The other, I think, key piece is that so we're governing not just tables, but also unstructured data like volumes, AI/ML objects like models and functions. What you can't see, because it's covered up by the captions, it was too hard to fit this. It's too hard to make this diagram. It's just like too rich with content. But right at the bottom, actually, we're talking also about expanding beyond different table formats with Delta Lake Uniform. So being able to support, for example, as part of our broader vision, Iceberg, Delta, Hoodie. It's not Hoodie, it's Hoodie. I checked. And then JSON, Parquet, and CSV. I don't know, I can tell that someone wants to debate me right now, but we're not gonna do that. And the other thing I think that's like really key, so focusing on this kind of red-orange box, Unity Catalog, it not only supports like these native Unity REST APIs, which is what gives you access to all of these different objects, but because it's so important for us to have universal interoperability, we also support the Iceberg REST Catalog APIs, HMS interface, and open protocols like Delta sharing to enable cross-domain sharing with third parties, for example. And so we're really excited because now Unity Catalog is open source. And so if you were at the keynote earlier today, woo, yeah, oh, thank you, yes. All right, and then hey TD. Now Unity Catalog is open source. You saw Matej make it live on stage. That was actually real. It was very nerve-wracking, but it turned out fine. And there's 3 pillars: open, interoperable, unified. I mean, this is really just a continuation of our commitment to making sure that organizations have the open foundations that they need for their data lakehouse. And of course, again, it's super important that this provides rich interoperability and unified governance for your data and AI assets. Okay, so best part is it's available today. Here's a little bit more on that. So we have the open API spec. So this is all, I don't know if you've checked out the GitHub yet, but this is all available on GitHub. We have some docs and stuff like that, but we have the open API spec, managed tables, external tables, volumes, functions, credential vending. That's all in this first kind of a 0.1 release is what we're kind of calling it. And then also an open source server implementation of that. This is all available live in the new Unity Catalog GitHub repo. We also have a bunch of developer resources available. We've updated the Databricks SDK because the best part is that Unity Catalog actually implements, so Unity Catalog and Databricks implements this open standard right from the get-go. And so what that enables is a bunch of really cool things, which we're gonna show you in a second, because we talked about all these problems, but now let's talk about how we're gonna solve those problems. But before that, I forgot I just added this slide last minute. But what this means for Databricks customers, 2 things. Continued commitment to open source. We're gonna continue to co-evolve Unity Catalog and Databricks and Unity Catalog open source projects with richer functionality. And then also enables full interoperability from day 1. So it means external engines and clients, the ones you want to use. I talked about being able to leverage best-of-breed tools with your data and AI assets. We're going to enable external client access to all tables and unstructured data in Unity Catalog. That's available today with those APIs. Okay, so, releasing open APIs is one thing, but we also know that true interoperability can only be unlocked with a rich ecosystem. And so this is also a great slide that I spent a lot of time on, trust me. And we're really excited because with this release, Unity Catalog kind of becomes like this super open and interoperable catalog for data and AI. We're really excited because we have these amazing partners. Actually, a lot of them are in the room. Thank you. You're almost like seat fillers. It's really encouraging for me. I think we have some amazing partners. Okay, no, I'm just kidding. I mean, you're more than that. We have some amazing partners, folks from Seller Data, CETA's here. They're a great engine for like low latency queries. I'm not sure if the folks from PuppyGraph are here. Oh yeah, okay, I love it, love it. Folks from PuppyGraph are here. You might be wondering what that is. It's not this, actually. It's actually their graph query engine over open data lakehouses. And then finally, as Matej mentioned, we have donated Unity Catalog to Linux Foundation, AI and Data Foundation. And so we're really proud to be a sandbox project there. And to be, yes, I know. Oh my God, the man of the hour right here, Denny. We're really excited to be continuing to partner with the broader open source community and some really amazing projects that are also in Linux Foundation, AI and Data. Okay, so here's what everyone is here for, I presume, is demo time. We're gonna put our money where our mouth is with a not live demo, but they were live recorded earlier.
Okay. Just want to make sure that things switch properly. Yeah, cool. Okay, so as Michelle said, I recorded the demo, but if you want a live demo, come to my next session. I'll take a part of this and make the live demo. There were too many things here, so I couldn't actually do it live. Okay, so I'm excited to show you all the capabilities that UC Open APIs provides. And to begin with, let's see how an external engine like DuckDB can access Databricks UC managed tables through UC Open API. Okay, so to set the stage, here I have, let's say I am the data admin for a sales team, and Michelle here is the data analyst. So I set up a catalog here called sales prod, in which there is a schema, analytics schema, and it has a few tables in there which are contain sales information. There's a purchase orders table. There is some stores tables related to store information. Michelle is working on some reports. She wants to have access to only the stores tables. So let's make sure that she has the right permissions. We go look at the permissions. No, she doesn't have access to purchase orders. That's great. She has access to both the store reports and store returns. That's great. So let's run a query inside in our Databricks SQL, and cool. So we have the results. But Michelle doesn't want to use Databricks. She wants to use DuckDB and wants to use DuckDB on these tables. So how do we make that happen? DuckDB happens to integrate with the UC Open API, and so I've set up a DuckDB instance. This is pointing to, can't see it.
Can you zoom a little bit?
Can I zoom a little bit? Let's see.
That's too hard. That's asking too much, I think. It's already.
Oh, it's a video.
It's a video.
It's a video, so I can't. Anyway, so I'm going to. You have to trust me on this. I'm attaching the sales prod into DuckDB, and
Exit full screen.
Exit the full screen, yeah. The video will be out in the middle.
I can exit the full screen. That would work. Yep, that would work. Thank you. Okay. So, and what did I do? After that, we ran the same query that I ran on Databricks, and we see that you get the same results. So that's great. Now, Michelle is done with her work on this particular table, and we want to, she doesn't need access to the table anymore. So as a good security administrator, I would go in and turn off access to her. So I go in and remove the privileges. And once we revoke the permissions, let's go back to DuckDB and
oh my God. I don't have access anymore.
Yeah.
What's happening? Denied, yeah, forbidden. Oh my goodness. I really wanted to do those reports.
I thought your reports were done. That's why I removed the access.
Oh, I mean, I thought, were they done? I don't know.
Okay, so this is the demo I'm going to show live in the next session, or if everything works. But yeah. So what we've seen here is that an external engine, DuckDB, can access UC tables, and we can apply uniform governance across both external engines, the same governance that applies to Databricks, within Databricks. So now, some engines may not integrate with the UC Open API today, but they integrate with, many of them integrate with Iceberg REST catalog. So the UC open source also comes with an Iceberg REST interface. And I'm going to, next one is demonstrating how an engine like Trino can access UC managed tables through the Iceberg REST interface. So the next thing I wanted to show was an ML application storing unstructured data inside UC volumes, right? So for that, I created a volume here called scans, and currently the volume is empty, and so you can see that it is empty. It doesn't have any data in there, and so after this, I'm going to use unstructured, which is an ETL for unstructured data, and I'm going to I have built this application that processes my PDF files, and the output of that it stores it in this UC volume. So the way it does that is, there is this volume writer, which is a Databricks volume writer, and that is connected to, as you can see, it's connected to the Databricks host there, and it's taking my username and my token, and the volume name. As you can see, the volume is scans. So then let's go try running it. This will take a few seconds to run. It's processing my PDF files, and then
The shout out here too is that our friends from Unstructured built this amazing integration, which is processing the PDF files, and then it's doing something.
So yeah.
And then it's going to spit out some amazing metadata.
So yeah, as you can see here, it uploaded the data to the volume. Now we can go back to UC to Databricks and see whether the data has been loaded there. Let's refresh the screen, and yeah. So
we're ready for some questions yet? Yes? I just want to make sure if we're ready for questions. That's all.
We can do questions on what we just saw. Otherwise,
Perfect.
I think actually it might be good to also finish the last demo.
Okay.
yeah,
Yeah.
Let's
and
do
then
that. Okay, you got it.
once the demo is
Perfect.
done, then I can, because then we can take more questions.
Perfect.
Yeah?
You got it.
Good.
Let's do that.
Okay. So that's unstructured, an ML application which does ETL for ML use cases, taking PDF, generating the unstructured data out of it, and then putting it in a volume, right? So the final thing I'll show is using UC as AI tool catalog, Gen AI tool catalog, right? And for this, my colleague Shangri has this list of functions that he has built, which are AI tools. And as an example, you have an AHA search feature. AHA is a product management application, and this tool goes to AHA and returns AHA tickets that match feature IDs, and then returns them in JSON format. And there is also like a search Wikipedia tool that which searches a Wikipedia snapshot and returns information from Wikipedia. So I've built an application based off of this. It's an assistant application, and the assistant here uses a tool calling agent, right? It uses these tools to look up and improve its results. And the input I provide, it's by being passed along as a prompt to this assistant, right? And as you can see, I've given the tools, the functions in that particular catalog that my colleague has created as the tools to use. So I'm going to go and ask this assistant to find all the MLflow related features and the assignees for those features. So as you can see, it's searching through the AHA. It knows that it needs to go search AHA for it, right? AHA is the product management application, as I said. It's searching for it, and it is going to look up all the features that tickets that match that, and then it's going to look up the assignees for those using the get feature. Okay. Takes some time to process all of this.
You know, there must be a lot of feature requests in AHA that it has to search through.
And there you go. So,
okay, wow.
so now, I also wanted to go and ask it. I think if it comes up, yeah. So I wanted to ask, tell me about the inventor of Spark. And let's run this and see what happens. So now it actually goes and searches Wikipedia for this, because AHA wouldn't have information about the inventor of Spark. So it
Kind
goes
of
and searches
interesting that it's
Wikipedia.
searching for Matteo Interlandi. That's interesting. I didn't know that was
And
the
then it
inventor.
and then it zeroed into Matei.
Oh, okay.
Alright.
Figured that one out.
Yeah.
AI is pretty good.
So yeah, so that's the. So overall, I think what this demos overall show is with the UCOC Open API, it's across data and AI. It serves the data and AI use cases. It is structured and unstructured data, and it provides universal governance for external tools with external access. So yeah, so with that, I think Michelle, I'll hand it over to Michelle to
that's
talk about
exciting.
what's next.
That's exciting. Okay, I think we just have one more slide and we can talk about questions. We can just do those ad hoc. But one more slide, and this is going to maybe preempt a couple questions, which is I think we mentioned that today is the sort of 0.1 release, just that very first initial release. What we have on the roadmap up ahead before we can reach that version 1.0, super high priority for us is the format agnostic table write APIs, like format agnostic commits API. Views, multi-dialect views specifically, implementing the Delta sharing open protocol, models, remote functions, and access control APIs. And so a lot of those are coming on up ahead, and we're really excited. Okay, and with that, I think that ends our talk, and then we can talk about questions. Yeah.